Welcome back. In the previous lesson, we learned that an image is nothing more than a NumPy array made up of millions of pixels. Today, we're going to take advantage of that by reading and modifying individual pixels. Let's begin by loading an image as we've done before. Since every image is stored as a two-dimensional array, we can access a pixel using its row and column. In OpenCV, the first value represents the Y position, or row, while the second represents the X position, or column. For example, image open bracket 100, 200 close bracket returns the pixel located at row 100 and column 200. If we print that value, we'll see three numbers representing the blue, green, and red intensities for that pixel. Because images are simply arrays, changing a pixel is as easy as assigning it a new value. Let's replace that pixel with pure red. Remember that OpenCV uses BGR order, so the value we'll assign is 0, 0, 255. If we display the image now, the change is almost impossible to notice. That's because we've only modified a single pixel out of millions. To make the effect visible, let's change a larger area by using a loop that updates many neighboring pixels. As the program runs, you'll start to see a colored square appear on the image. This demonstrates an important concept. Every image filter, drawing tool, or computer vision algorithm ultimately works by changing pixel values. Whether you're blurring an image, detecting edges, or identifying faces, everything begins with reading and modifying these numbers. Before we finish, try experimenting with different colors. Change the pixel to blue, green, white, or black, and observe how the values change. It's a simple exercise, but it helps build an intuition for how digital images are represented. In the next lesson, we'll learn how to save our modified images to disk so the changes we make aren't just temporary. They become new image files we can use later.